All right, so I want to call your attention to the fertilizing Pinot Navy under dry edible bean. There's also a companion circular that I'll mention later on that talks about the in-furrow placement, and I'll go through that. But anyway, this is your go-to guide for anybody in this state anyway. So I want to start with nitrogen. The nitrogen nutrition of dry bean, very odd. You can inoculate it, but its effects are very inconsistent, and that's because the nodules will slough off if it's too wet, too dry, too hot, too cold, too much soil salt, and so it's very different than, say, soybeans and field peas and some other things that have a good relationship. So in my early part of my career, gathered data from my work and from others, and this is a response to nitrogen. The no inoculation is that very shallow positive curve up at the top, and then the inoculated trials with nitrogen added is the one that kind of goes down, and so there's a very, very shallow shoulder, and so your risk of doing anything horrible, wrong, is very low, but there is a economic benefit to applying some N in a lot of soils, and the survey shows that most of our dry bean growers in the region use some nitrogen. But the idea of inoculating and putting on nitrogen, to me, is not very useful. One of the things that happened is some work from Manitoba. If you look in the left-hand graph where it has environment times N rate, the two environments, C17 and P18, notice as the nitrogen rate goes from 0 to 140, the nodules that are on the plants goes way, way, way down. So if you're thinking maybe your nodulation is really where your nitrogen is coming from, but you want to put some nitrogen on anyway, what you're going to do is you're going to decrease the potential for any kind of nitrogen fixation. And so to me, it's really a either-or proposition. I showed you the response curve that we had, the very shallow quadratic curve in Manitoba a couple years ago. Did the same kind of study over a few environments, and they found they had about the same quadratic curve that we have. So small increase in yield with nitrogen rate, but it flattens out somewhere around 70 to 100 pounds of N. So that's nice to know that our work is still valid. Response of dry bean to nitrogen and nodulation is pretty small. So that gives us with three possible nitrogen strategies. And the first one is do nothing. And that might come as a shock to some and not to others. There are some very good soils in the state that have been in dry bean production for a long time. They don't have any conditions where they have standing water. The soils are very friable and very tilthy, and so you can go in the middle of the season after they're haven't done anything to them, and pull plants out of the ground with your hand, and there's nodules all over the place. And so there's no reason to put nitrogen on those fields. They do well anyway, and there's no reason to put on more inoculant because they have plenty anyway. And so do nothing is a valid nitrogen strategy for some. Number two, inoculate. These would be fields that probably been in dry beans maybe for the first time or maybe for the second time, where there aren't any places where water will stand or too dry, pretty decent soils, and some growers do just fine just inoculating. And then there's soils that have issues from place to place, and so fertilizing up to 70 pounds of N per acre, and then you subtract the soil test N to 2 feet, any credits that you might have, like sugar beet leaves, from that. There are some people that grow in navies that have really high yield potential, either irrigated or non-irrigated, and they're most successful if they're putting on more nitrogen than that. But some of those yields are, up to 4,000 pounds an acre or so. And so they just need more nitrogen, so the rate is higher. But I would hang my hat on pintos in this region, or anything that yields like pintos at that 70 pound of N per acre rate. So those are the three strategies. With phosphate, dry beans are not a great responder to phosphate either. The recommendations aren't related to yield goal because it doesn't really make any difference. The high range starts around 12 part per million. Even if you get down to the low range, we're still thinking about rates of phosphate that are less than, say, 100 pounds of MAP per acre easily. So not a whole lot is required. So this is a little bit of a change in the last couple of years. Greg at Carrington and others have done a series of studies. Our recommendations in the past have been no fertilizer with the seed, and Dr. Condell mentioned this a little bit in his presentation. So they had a series of studies, and what they found is that low rates of 1034.0 or something like 1034.0 in furrow is really better than broadcast. This is untreated versus in furrow on the right, and a nice increase with 2 to 3 gallon per acre of 1034.0. This is in furrow versus band, and by band that is just some distance between the seed and the fertilizer, and probably an inch or two, and about the same kind of yields. So if you're already set up to band away from the seed, I don't think I'll do anything different than what you've done before. But if you haven't done anything with the seed and you're thinking about broadcasting, maybe in furrow a little bit is not a bad idea. Because when we look at the broadcast application compared to the in furrow or the band, there's a nice yield increase there, which is totally unexpected as of 20 years ago, but maybe with the different varieties, this is a little bit different. So this is okay. So 2-3 gallon an acre. This is the mid-row. You get good questions about mid-row band all the time. Mid-row is not a good band to use. It's too far away from the seed, and it doesn't seem like it's very available, does it, compared to the in-furrow or the band in particular. And then rates. There's no reason to go higher rates. In fact, it's probably to your disadvantage economically, both maybe yield-wise and certainly dollar-wise for the fertilizer to go to, say, 5-6 gallon an acre instead of 2.5 to 3. So on the left is the 2.5 to 3 gallon an acre 1034.0, and on the right is the higher gallonage. And the reason you put on fertilizer is to make money, and you're not making any money by doubling rates. So do the low rate. So if you want to know more information about this, you can do a net search for NDSU PIT-OP, and it'll give you the phosphorus starter fertilizer. This publication is also on my website too. If you don't want to wander through the extension one, you can, mine is either linked to it or downloaded right on my page. So refer to this if you have some more detailed questions. Potassium, dry beans are not a big responder to K in the earth soil. So if your soil test K is greater than 80 part per million, no matter what your clay type is, you're going to be fine. You're only going to think about potassium if your soil tests are below that. All right, so the next fertilizer that people regularly use is zinc. And then there's sulfur is a big question right now. We're coming off a wet fall, and so far it's been a little wettish this spring. I would anticipate on our small grains and corn, we might have some sulfur issues. What about dry beans? I don't know. Here's some work from Carrington coming up. One thing to understand about the zinc is the more organic matter you have, the lower you are in the landscape, the deeper your organic matter is, the less problems you're going to have with the zinc. If you're doing some soil sampling and you have variable soils, I would, which includes almost everything, I would suggest the zone sampling, because zinc will differ depending on whether you're at a hilltop or a slope or a depressional area. And so dividing the field up into your zones will help you with your zinc decisions. So our soil test is very good with zinc, and so 6-inch composite core, zone sampled. If your soil test is less than 1 part per million, small rate of zinc in the starter band is going to alleviate any deficiency. Any rates, 1 point to a quart are sufficient. All right, now the sulfur. Sulfur has really become a problem. Our yields are higher, and our sulfur from the air is a lot lower. On the left-hand side is the sulfur deposition in year 2000 and in 2016, and the latest one is even lower than that. So we're only getting maybe about 2 pounds of sulfur per acre per year from the atmosphere, and we used to get 2-3 times that rate, and so the atmosphere is not helping us. We don't get acid rain anymore. We don't have any firm sulfur recommendations for dry beans. Don't use the soil test. It's garbage. Don't even bother. Our sulfur responses historically over the last decade have been more likely if we have wet weather in the fall and the early spring, and that's kind of where we are right now. Don't use elemental sulfur. It's not an option to even consider. Use sulfate sources, and don't put ammonium thiosulfate with the seed, and don't put ammonium thiosulfate with the seed. So here are some trials from Carrington that I tease you with a little bit later. This is the N-furrow 1034-0, and then adding zinc, and a bit of a yawner there. That's over about 4 years on a low zinc test, and so not much of a response there. And here we have a foliar zinc trial, and the foliar zinc wasn't all that helpful either. And this is foliar sulfur, and there actually was a response to that. So again, sulfur is not something we really think about too much, but if you have loamy soils, a little bit coarser, we've had all this wet weather, sulfur is not all that expensive. A little bit of ammonium sulfate if you're putting on nitrogen anyway, which most of you are, most of you will, then adding a little bit in there is maybe not a bad thing. If you're using the MES product, which has some sulfur in it, maybe that would be enough. It doesn't really take a lot of sulfur, as the study shows, for any kind of response to happen. So Carrington's been building up their database, which is great. They've had a number of experiments of in-furrow zinc, foliar zinc, pre-plant, foliar sulfur, and then various premium starter fertilizers compared to 1034-0. Really no difference between any of those products as far as response, but it's nice that they've been doing that work. And then finally, one of the things that you really consider, I know that the acreage of dry beans is going to expand this year. So as you're figuring out what fields to put it on, maybe don't decide just on convenience from wherever else you have dry beans. Take a look at your soil test. Don't put it on a field that's really salty, because dry beans is probably our most sensitive crop of anything that we plant large acreages of. Notice with this Colorado work that once you hit a little bit over 0.5 in a soil EC, the same kind of EC we get on our soil tests, that we start to reduce yields once we get up to 1, which isn't all that salty. There's a lot of fields around it that have a 1 EC. We've already reduced the yield by 20%. So we hope in the future that we get some of our newer varieties and test those out and see how they compare. Right now, this is as good as it gets. So my warning is that if you have fields that have a substantial amount of the field that is 1.5, 2, something like that, that's really not a field that's going to support high dry bean yields. So try to get something that's a little bit on the lower salt side. So with that, whip through that pretty quickly. And this is my contact information for those of you that don't have it already. Phone number, email, I respond to all texts. So thank you for your attention.